Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over question 1 from the 2019 SQA National 5 Physics exam paper, so let's get going. Question 1 says a quadcopter is a drone with 4 rotating blades, and you'll see a picture of it there. Part A says in a race the quadcopter is flown along a route from point A to point E. So the route goes 16 metres from A to B, then 11 metres from B to C, then 4 metres from C to D, and then another 6 metres from D to E. Part 1 says by scale drawing or otherwise, determine the magnitude of the resultant displacement of the quadcopter from point A to point E, and there's 2 marks available here. Well, here we want to use either the scale diagram or calculation method, and I'm going to use the calculation method here, so I'm going to draw a sketch on my diagram to create a triangle, and because we want the magnitude of the resultant displacement, my triangle needs to include that, so the shortest distance from start to finish here is from A to E, so that's going to be my resultant displacement vector from A to E. So that means I could draw my first displacement vector going from A to this point, which is above E, and that's going to be 12.0 metres, and we could label that A. And I know it's 12 because this whole thing is 16, remember, but this smaller section is only 4 metres. So 16 take away 4 gives me this remainder of 12 metres. And I could then draw my second displacement vector nose to tail here, which is going from here to here. And this time this is going to be 5 metres, and we could label that B. Now I know this is going to be 5 metres because the full length from B to C is 11 metres, but this was only 6 metres up to here. So 11 take away 6 gives us the 5 metres. And then just like we said earlier, we can draw a resultant vector from the start to the finish point. So that's going from A to E, and we can draw our double arrows on there to show it's the resultant vector. We could then label the hypotenuse as C, our right angle, and our angle theta next to the starting point. And then to find the hypotenuse C, we can use Pythagoras, so that's C squared equals A squared plus B squared. Substituting in the numbers gives 12.0 squared plus 5.0 squared, which is equal to 169. And then to get C on its own, we can take the square root of both sides, so the square root of 169 is 13.0 metres. Part 2 says by scale drawing or otherwise, determine the direction of the resultant displacement of the quadcopter from point A to point E, and again there's 2 marks available here. Well, we can use either the scale diagram or calculation method here, and to keep it consistent with part 1, we're going to continue using the calculation method. So just a reminder of what our triangle looks like, we've got our first vector A is 12 metres, second vector B is 5 metres, and our resultant there that we've just worked out is 13.0 metres. We can then label our right angle and our angle theta, and remember to find direction we need to calculate the angle theta, which always uses tan theta. So we're going to use tan theta equals opposite over adjacent. Opposite the angle is 5 metres and adjacent is 12 metres, so we have 5.0 divided by 12.0, and then to get theta on its own we can take the inverse tan or shift tan in your calculator of 5.0 divided by 12.0, and that should give you an answer of 23 degrees. And now to find the direction we want to use either compass points or bearings. Well, using compass points first of all, remember this is our starting point here, and this is east and then south down here. And the resultant vector you can see is pointing at an angle of 23 degrees south of east. So we could say the direction is 23 degrees south of east, or if you wanted to state the direction as a bearing, remember we always go to the starting point and think about north as 0, 0, 0, and you want to move round from north until you get to the resultant vector. So imagining a line here, we could start at north and go round 90 degrees to get to here, and then another 23 degrees to get to our resultant vector. So that's 90 plus 23 gives us 113. So that's 90 plus 23 gives us 113. So you could state this as a bearing instead of 113. Part B says the quadcopter takes 32.5 seconds to complete the race. Determine the average velocity of the quadcopter over the whole race, and there's 3 marks available here. Well, writing down what we know from the question, we're trying to calculate the average velocity v bar. We know the displacement s is 13.0 metres, and that's our resultant displacement we just calculated in part A. And the time t is 32.5 seconds, which we're told up here. So writing down our equation relating average velocity, displacement and time, we have s equals v bar t. Substituting in the numbers gives 13.0 equals v bar times 32.5, and to get v bar on its own we need to divide both sides by 32.5, so doing that in your calculator should give you an answer of v bar equals 0.40 metres per second. Because average velocity is a vector, remember, we need to add a direction. So our direction can either be at 23 degrees south of east, or we could say it's 0.40 metres per second at a bearing of 113. So you don't need to write both of these, just one of them. And it makes sense to use the direction that you used in part A. Part C says a second quadcopter completes the race at an average speed of 1.25 metres per second. The distance travelled by this quadcopter during the race is 37.0 metres. Determine the difference in the times taken by the quadcopters to complete the race. And there's 3 marks available here. Well, first of all, we want to calculate the time of this second quadcopter given some information about its average speed and its distance travelled. So we're going to calculate the time t. We know the distance t is 37.0 meters and the average speed, not velocity this time, is 1.25 meters per second. So writing down our equation relating average speed, distance and time, we have d equals v bar t. Substituting in the numbers gives 37.0 equals 1.25 times t, and to get t on its own we divide both sides by 1.25, and putting that into your calculator should give you an answer for t of 29.6 seconds. So to find the difference in time, we take the larger time and take away the smaller time, so that's 32.5 seconds minus 29.6 seconds, and putting that into your calculator should give you an answer of 2.9 seconds. Lastly, part D says after passing point E, the quadcopter hovers at a constant height. Describe how the overall lift force provided by the 4 rotating blades compares to the weight of the quadcopter, and there's 1 mark available here. Well, the keywords in this question are constant height, so we can say that a constant height means the forces are balanced, or the forces are equal in size and opposite in direction. And you don't need a sketch here, but if you did want to draw one, it would look something like this. So here's our quadcopter, we've then got the weight downwards, and this is balanced by the lift force upwards. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.